Scaling here in 3 dimension is similar to scaling in 2 dimension. That is not a big thing. Okay, we are just having a factor. This factor is multiplied with the x coordinate and whatever x, y and z coordinate. Earlier in 2 dimension it was being multiplied with x and y. Now it is being multiplied by x, y and z. That's it. So if you want your new coordinate position x dash, it will be your original x position into some factor. Similarly, y dash will be original y position into the factor to be multiplied with y, and z dash is z dot sz. Simple. So if you want to represent this in a matrix, so your matrix should have x dash, y dash, z dash and 1 in a result. It will be the result of multiplication of 2 matrices. One is x, y, z and 1 itself, and here it is the scaling matrix. The scaling matrix, I believe here it is a homogeneous coordinate and no translation. So this is something. In the diagonal you will mention sx, sy and sz. Other places it is 0, right? This matrix will work for your scaling. One thing here you can understand that what is happening, the size is definitely increasing. However, with increase in the size, the object is also moved from one position to other, because the x coordinate value, whatever, and these coordinate values are also doubling. So in that case, the object looks like it has moved from one position to other. So in that case, what you need to do, you know what you need to do, right? You need to perform this scaling in 3 steps. The first step was to translate, and bring to origin. Okay, suppose this was your object and you want to scale it. What do you want to do? You want to scale it with I should say relative to, scale it relative to a fixed position or fixed reference point. Okay, with reference to a relative to a reference point. Then translate. So what you need to do, first step is translate to origin, wherever it was. From there move it to origin. Okay, then what you need to do, perform the scaling. You are moving this object to the origin, which means at the origin you should have your reference point. Okay, then you are performing the scaling. Okay, perform your scaling, whatever your factor is, relative to the origin. Perform a scaling relative to origin. So earlier that you have done here was relative to origin. Now the third step. In the third step, what will happen? Once you have performed the scaling, it has scaled, the size is increased. Now you need to move it back to the original position, right? So perform the inverse translation, right? Perform the inverse translation. in order to move the reference point, move this origin to the reference point, right? Okay. So this is how you will do. For this, you will make a matrix. Matrix will be, you will perform the translation first, and suppose for translation factor, whatever it is, then you will perform your this thing, scaling, and then inverse translation, right? So for translation, if you are using something, some factors, or x factor, let me add sx, right? Sx, no, it's okay. Tx, ty, and tz, right? So here you will use minus of those things, tx minus ty and minus tz, okay? And definitely there is some scaling factor, sx, sy, and sz. So if you will multiply these three matrices and try to form a composite matrix, how will it look like? It will be sx, sy, sz, and 1. Other places, definitely here it will be 0. However, here in translation place, it will be once it will be translated. So tx, and again it will be done this thing with this. So we have seen this kind of matrix earlier, and on the basis of that I can say it is 1 minus sx into this factor tx, 1 minus sy into ty, and 1 minus sz into tz. Okay. Other places it is 0. So this composite matrix, if you will use, you can perform this kind of translation, moving to the origin, and then rotation, then the scaling, and then translating it back. This is the story of your scaling. Till now, if you have any question, you can ask. So in reflection, what is happening? Earlier we have seen 2D reflection, where the objects in quadrants were changing. What was looking here, and changing the values of x, you can get the object here in this quadrant. Now not only the plane, we are changing the whole object from one dimension, right? I should say, if you are considering a plane xy, then the reflection in z dimension, I should say, will be visible on a minus z side. Okay. So for this, what you need to do, you have just to understand that z has become minus, right? So suppose I am writing reflection relative to xy plane. Okay, relative to xy plane. So what will happen? Your this matrix for reflection which will happen on z, what it will be? 1 1 1 1 0 0 0 0 0 0 0 0 0 0 0 0. Okay, this is your matrix. Oh, it will produce the same thing. Okay, if you keep it a minus here, only the z values are negated. Okay, so whatever object was on this side, it will appear on the other side. This is a reflection. Now if you want to do the same thing with respect to this yz plane, in that case the x values which was positive, it will become negative. Similarly, if you want to keep this thing constant, x and z, then whatever the values of y were there, it will go down and it will be minus y, right? Negated. So these are the few things you have to consider in a reflection. Very simple to understand. Any question? No. Similarly, you will have your shear operation also in 3 dimensions. Okay, what happens in shear operation? If you remember in 2 dimension what was happening, your one object here was looking, which was moved in a particular direction in a staged fashion, right? So it will appear something like this, right? So same thing is going to happen in 3 dimension. Okay. Okay, whatever the object you have, this cube, if you will perform some kind of shearing, then maybe you will give 2 dimensions, the values to change in 2 dimensions. In that direction it will keep on changing. Okay, so for this, what will be the matrix? Suppose you want to perform z-axis shear, right? So I am writing SHZ. In that case, what will happen? This is the homogeneous coordinate 0, 0, 1. Okay, and then the diagonal and z-axis. On the z-axis, some values need to change. X will also change and y will also change. Other things are as it is. Okay. These parameters a and b are some real values. What will these parameters do? They will change the values of x and y coordinates here. However, they will not change the values of let me repeat what I am saying. It will change the value of x and y coordinate with the proportion of z value. Okay, whatever the z value was, initially this is your z direction, so initially this was your z value. X and y value for these all the pixels will change in proportion to whatever the value of z was. Earlier the z value was small, it will change, it will have a smaller change. Okay, it will look like this was same thing, this was same thing. Okay, okay, okay. Something like this. This, whatever it was lying to the this axis, these all the coordinates x and y values will change according to the values of z, how much value it is having, right? Okay. Here we have to understand that the z values, that the amount of the object was in z direction, that much it is still here only, only the x and y values has changed, so it looks a little elevated. Okay, that's it. So this is your shear operation.